Hello, class. We are starting on chapter 3, and chapter 3 will deal with certain functions. If you recall, in chapter 2, we covered what a function is, and we looked at some parent functions and just their basic graphs. So here, we're going to focus on a particular set of functions called polynomials. That's going to be the bulk of chapter 3. We will look at how to graph them, how to solve them, and then the last section we will take a look at another type of function called rational functions, and we will look at how to graph those as well. Okay, so this chapter is very big on graphing and solving. Okay, so 3.1. Here we are going to just focus on quadratic functions, so the parabola. Okay, so let's first start off with the different parts of a parabola. So if you are familiar with the parabola, there are certain characteristics, particularly the vertex, which is important. Okay, so we'll look at one where it opens upward and one where it opens downward. Okay, so suppose that I have this graph here. Okay, and suppose I have this parabola that opens upward. Okay, so we have very particular parts here. Right here, this turning point down below, right over here. This here is the vertex. Okay, so this one is the vertex. And in this particular case, it is a minimum value. Okay, let me go ahead and graph the other one so you can compare. If you have the parabola that opens downward, okay, then the vertex is up here at the very top, okay? And in this case, this here would be a maximum value. It's the highest value, okay? Whereas on the left graph, it's the lowest value, so that one is the minimum value, okay? We also have this sort of imaginary line that goes through the vertex for both of them. Okay, so this imaginary line slices this parabola in half so that it is symmetric. So we call this the axis of symmetry. Okay. So same thing with the one on the right, axis of symmetry. Okay, and we know that for all graphs, the points where the graph cross the x-axis, those points are called the x-intercepts. So let's point there. That's an x-intercept, and this is also an x-intercept. Okay. Over here on the right, the x-intercept would be here and here. Okay. And then the y-intercept, hopefully you can find the y-intercept here on the left. It's where the graph crosses the y-axis. So this one here is the y-intercept. And over here on the right, the graph on the right, the y-intercept would be right there. Okay, y-intercepts are pretty easy to find with functions because you just let x be 0 and solve for y. X-intercepts take a little bit of work. Okay, so let's take a look at quadratic functions. So quadratic functions are polynomials with degree 2. Okay, and so what we're doing here in chapter 3 is we're going to be looking at higher degree polynomials. So this first section is degree 2 polynomial, which is a quadratic function. Then we'll look at degree 3, degree 4, degree 5, etc. Okay, so in this section, we're going to look at two forms of the equation. So we're going to look at something called expanded form and then another one called standard form. Depending on which book you use, some books will call expanded form standard form. So it doesn't really matter what we call it. You just need to be able to recognize which form you have and apply the methods for finding the vertex to each one. Okay, so let's call this expanded form. So we'll look at that one. And we will also look at standard form. So okay, so for expanded form, it looks like this: f of x equals ax squared plus bx plus c. Okay. It has to be a degree 2, so a cannot be 0. Because if a is 0, then you don't have degree 2, you have a degree 1. Okay, so a is not 0. And standard form, so here for expanded form, you don't have these parentheses, you have this all multiplied out. With standard form, sometimes it's also known as vertex form. That would look like this: a parentheses x minus h squared plus k. All right, so here we see that we do have this grouping of this binomial squared. Okay. All right, so notice here that the only thing that these two things have in common is the letter A. Okay. And it turns out that those two A's are the same value. So if I had a quadratic and it was written in the first form, and then I rewrote it so that it looked like a standard form on the right, that A value will remain the same, whether I have it written in expanded form or standard form. Okay. All right, so that A plays an important role with how your graph is going to look. If A is greater than 0, so if it's positive, then your parabola will be open upward. If A is negative, less than 0, then your parabola will open downward. Okay, so over here, so we said here that this is the same as the A value in expanded form. Okay, so therefore, if A is positive, you will have a parabola that opens upward. If you have A is negative, then your parabola will open downward. Okay. All right, so we already said that one of the key points on a parabola is the vertex. So we need to be able to, whether we're in expander form or standard form, we need to be able to find the vertex. Okay, so vertex. So if you are in expanded form, then you would find the vertex using this formula. X equals negative parentheses b all over 2 parentheses a. All right, so this is how you would find the vertex. So we are going to take a look at graphing next, and we will need to find the vertex. Okay, so you would use this formula to find the y value, x value, and then of course it's a point, so you will need to find the y value. Okay. So a couple of things about this. This is also the axis of symmetry. Okay. And then we said we need to find y value. Okay, so you find the y value by plugging in this x value into the function. Okay. Okay, so that's how you find the vertex if you are in expanded form. If you are in this other form, standard form, then here the vertex is actually pretty easy to find because you just have to take a look at the function, and the vertex is already embedded in this standard form. So it's right over here where you see this h, and it says minus h. So it's where the h is. And you see this k right over here. That would be the y value for your vertex. So keep in mind that here the h value is the h value that's up here in the equation. However, you need to make sure that it says minus h up inside there. If it doesn't say minus h, you could always rewrite it. Okay, so we'll take a look at that when we are actually graphing. Okay, so but that is something you will need to pay attention to. Okay, so here it's sort of the opposite. So that if it says negative h, you take positive h. Okay. All right, let's have a look. So let's take a look at graphing. So let's just keep in mind vertex over here, when we have expanded form, we're going to be using this formula. When we have it in this sort of vertex or form or standard form, we are just going to identify it. Okay, so not a lot of work for finding the vertex there, which means we will start with the first one, the first form, which requires a little bit more work. Okay, all right, so graphing. Okay, so when you're graphing a quadratic, a parabola, you only need these things. If you have these things, you will be able to graph it. You don't need a ton of points. You do need the vertex. Okay, so imagine having just the vertex plotted. Clearly, that's not enough. Okay, so we will need one extra point. And you can get this extra point by choosing an x value, plugging it in. It doesn't matter what x value you choose an x value and plug it in, you get an extra point. Okay. Of course, if 0 is available, that's a nice one to choose. Okay, so we're going to get this one extra point. We plug it in, choose an x value, plug it in, get your y value. Okay, so we'll have the vertex. So try to imagine the vertex plotted. Try to imagine 1 point plotted. That's almost everything we need. With those two things, we get half of the parabola graph. So to get the other half, we're going to plot a third point. But this one, we don't need to calculate. This one, we are going to get by symmetry. Okay, so the only work necessary for graphing is going to be here when we calculate the vertex, unless we're in that other form where there is no calculating, you just have to look. Okay, and then this one extra point. Okay. All right, so let's take a look at graphing standard form. Actually, that one's the easier one, so let's do expanded form. So this one is the one where you need that formula for the vertex. Okay, so that's the one that looks like this. Okay. Okay, so let's go ahead and graph f of x equals negative x squared plus x plus 2. So here we see here, because a is -1, it's going to be a parabola that opens downward. Okay, so a is -1, b is +1, and c, which we won't use it in the formula, but it's nice to be able to identify all of these things. Okay. All right, so let's go ahead and find the vertex. So again, we need the formula, x equals negative b over 2a. Okay, so here we're going to use negative parentheses, b is 1 over 2 times a is -1. Okay, so we're going to use those numbers in our formula. And working this out, we get -1 over -2. So we have this double negative here, which becomes +1/2. Okay, so again, this we don't have the entire vertex here because we need the y value. However, this x value of the vertex also represents the axis of symmetry. So let's go ahead and start our graph here. So here's 1, 2, 3, 4. Okay, so at x equals 1/2, we have the axis of symmetry. So I'm just going to do my sort of ghost line. Okay. And so I have my axis of symmetry. I need the rest of my vertex. So let's get the y value. So I get my y value by taking this x value over here and plugging that into the function. So y equals, there's -1/2 squared plus 1/2 plus 2. Very important to use your parentheses. That way you can keep track of your negative signs. Okay, so here you have to do exponents first, and then you can multiply by that negative on the outside. So that's going to be negative out here, and this is 1/4. Okay, and I'm going to turn these all into fractions. So I'm going to put that 2 over 1. So this is going to be -1/4. And LCD is 4, so this is going to be 2/4. And this one over here will be 8/4. And then all together here, I get 9/4. Okay, which is 2 1/4. Okay, so then that means that my vertex is at the point +1/2, 2 1/4. Okay, so let's go ahead and plot that. So 1/2, 2 1/4. So right around here. Okay. And now, so we have the vertex, but if we take a look up here, we need the vertex and we need one extra point that we are going to calculate. And then we'll get the third point by symmetry. Okay, so the extra point, I'll do the work over here. So again, to get that extra point, you can choose any x value. I love 0, and you can choose anything except for this x value because you need an extra point. If you choose 1/2, you're just going to get 2 1/4. You don't have another point. You have the vertex. Okay, so you need to choose an x value that is not the x value in the vertex. Okay, so since the x value for the vertex is 1/2, I'm going to choose my favorite number, 0. So I'm going to choose x equals 0. I'm going to plug that into the function, and I get 2. Okay, so I have the extra point 0, 2. Okay, now it's very important to include this axis of symmetry here because oftentimes when students don't put that line of symmetry, they have these 2 points there, and oftentimes students will forget which one is the vertex, and they get so used to drawing their parabola open upwards that they mistaken that 0.02 for the vertex, and then they completely mess up the graph. Okay, so here doing this line of symmetry here helps us to keep track of where the vertex is. So we know this one is the vertex. Okay, the other one is the extra point, and we know that by symmetry. So here we only have half of the parabola, and we can get the other half by symmetry. So over here, this point is, this one here is 1/2 away from the line of symmetry. So the other point will be right here, 1/2 away the other direction. And now you can get the rest of your parabola. Okay. So again, we get that third point by symmetry. Okay, let's try another one. Okay, I'm going to have you guys try this one. So try graphing f of x equals x squared minus 2x plus 2. Okay, so go ahead and hit the pause button, give it a try, and then come back to see if you get the same thing that I have. And then by symmetry, if I have a point over here, then, and that's 1 away from the line of symmetry, so I will have a point over here that is also 1 away from the line of symmetry. Okay, so hopefully this is the graph that you got. Hopefully you got 1, 1 for the vertex, and maybe you got 0, 2 for your extra point. If you chose a different x value, then of course you'll get a different point. But if you chose 0 for x, then you should have gotten 2 for y, and this is the graph you should have. And you should have all 3 of those points. Okay, again, if you have any questions, make sure you text me or email me. Okay, let's take a look at graphing the other kind of form, vertex form or standard form. So again, depending on which book you use, it calls it standard form or it calls it vertex form. So graphing standard form. Which looks like this. Y equals ax minus h squared plus k. So let's take a look at that one. Again, so this one is a little bit easier because you don't have to calculate the vertex. It's pretty much embedded in the actual equation. Okay, so let's take a look here. Let's go ahead and graph f of x equals 2 parentheses x minus 3 squared plus 1. Okay, so you might be looking at this and thinking, well, didn't we do this in chapter 2 where we did the shifting? The answer is yes. So you can apply all of the things that you know about shifting to this particular problem. Okay. Let me show you another way to graph this using the vertex and one extra point. So here we said the vertex is at h, k. So here we are going to have 3, positive 3, and positive 1 for the vertex. Okay, and I need one extra point. And in the last form, I liked using 0. But here, if I use 0 for x, I get 3 squared, negative 3 squared, which is 9, and then times 2 is 18. I end up with larger numbers. Okay, so here, I'm not going to choose 0. I like to choose an x value that makes this inside answer very small. Okay, so I'm not going to choose 0. I will choose positive 4. That way I get 1 on the inside. However, it's up to you. You can choose whatever you want. Okay, so I'm going to get y equals 2 times 4 minus 3 squared plus 1. And that's going to be 2 times 1 squared plus 1. And you have to do exponents first, then multiply. So that's going to give me 2 times 1 plus 1. And that's going to give me 3. Okay. So my extra point here is 4, 3. So once you have the vertex, and we do, and an extra point, which we do, then you can go ahead and graph this. And again, we get that third point by symmetry. Okay, so let's go ahead and graph this. 1, 2, 3, 4, 5. Okay, so 3, 1. That's my vertex. And I have my line of symmetry. And going through there, again, it helps you to keep track of the vertex and how to get that third point by symmetry. So 4, 3, 1, 2, 3, 4, 3. I have my extra point. So I see I have half of my parabola now. And I get the other half by symmetry. So if I have this point is 1 away from the axis of symmetry, then I will have another point on the other side, 1 unit away from the line of symmetry. Okay, and you get the other half of your parabola. So here, clearly much easier to graph this one because the vertex is already in the equation. You only have to calculate that extra point. Okay, writing in standard form. Okay, so we're going to take a look at how to go from one form to the other. Okay, so let's take a look at, let's do standard form to expanded. So here, all you have to do is multiply everything out. So let's go ahead and write y equals 2 times x plus 3 squared minus 1 in expanded form. Okay, so I'm going to take this equation here and I am going to multiply this out. Okay, so x plus 3 squared, I'm going to work that out. So 2 times x squared plus 6x plus 9 minus 1. Now I'm going to distribute that 2. So 2x squared plus 12x plus 18 minus 1. And combine like terms. So 18 and negative 1. Okay, so here your standard form then is this final equation here, y equals 2x squared plus 12x plus 17. Okay, so going from this vertex form to expanded form, you just multiply this all out. Okay, going the other direction is a little trickier. Let's have a look. Okay, so now let's go from expanded form to standard. So this one here, you will need to use the method of completing the square. So if you don't quite remember how to do completing the square, I will have another video after this one that shows you how to complete the square. Okay, so let's take a look at this example here. Let's write f of x equals negative x squared plus 6x plus 4 in standard form. Okay, so I'm going to go ahead and bring this equation down here and do all the work. Okay, so for some students, it might be easier if we move this over to the side. Okay, so f of x minus 4 equals negative x squared plus 6x. So this is what we have. And then we complete the square. However, we can only start completing a square if that leading coefficient is right here is +1. Okay, so what I'm going to do here is factor out that negative. So the left side will remain the same. This negative will be factored out. And what I want to do is find a third term over here that works out nicely. Okay, so those of you guys who remember how to complete the square, the way you find this third term is by taking half of this b value. Okay, so that's our b value, and dividing by 2 and squaring it. Okay, so we are going to do 6 over 2 and squaring it. Okay. And yes, I'm going to ignore the sign right now because what happens is when you square a negative, you end up with positive anyway. Okay, so 6 over 2. So what happens is over here, since we're adding this value on the right-hand side, we also have to add it on this side. But you have to be very careful. So over here, this is 3 squared. But we actually have minus, because that negative is going to be distributed. So this is actually negative 3 squared on that side. So if we are putting a negative 3 squared on that side, then we have to put a negative 3 squared on the other side. Okay. All right. So this is what we end up getting. F of x minus 4 minus 9. And on the other side, this actually factors out to negative parentheses, a binomial squared, and the binomial turns out to be this. So that's x. This sign, so that's minus. Waiting for the video. There we go. And this number. Okay. So we get the x, the minus, and the 3. So here we get f of x minus 13 equals negative parentheses x minus 3 squared. We're not quite done. So now that we finished the right-hand side, we can go ahead and bring that 13 back. So let's go ahead and bring this back to the right-hand side. So we get f of x equals negative x minus 3 squared plus 13. So this here would be the exact same function rewritten in vertex form or standard form. Okay, so again, if you were a little bit lost with completing the square, then watch my next video on how to complete the square. Okay, that is it for 3.1. Again, if you have any questions, make sure you email me or you text message me. Have a good day.